Hello there, third graders. Third graders, we are doing lesson 7.3 today and looking at different ways to measure things and some real world problems. Here is the math message. So I'd like for you to read this. I'd like for you to think you might need a scrap sheet of paper to try to figure out the answer. All right, let's see what we have here. And we'll see how we did, right? This is just kind of where we kind of see, where we're headed in our lesson today. Sanjay catches the bus at 2:05 p.m. It takes 40 minutes to get to hockey practice. Practice starts at 2:30 p.m. How many minutes late will Sanjay be for practice? If you know me, whenever I see time, I draw these timelines. Right? They can be very, very helpful. So he catches the bus at 2:05. These timelines really help you to visualize and to represent time. It takes 40 minutes to get to hockey practice. We'll do a jump here. 40 minutes. What time does he get to? Remember, this is a 40-minute jump. What time does he get to practice? 2:45. Let's see. Oops, skipped a part. Practice starts at 2:30. So practice was right here. How many minutes late? Oh, he's late. I do not like being late. He gets here at this time. He was supposed to get here at this time. So look and see. How many minutes late was he? He was 15 minutes late. In a complete sentence, Sanjay will be 15 minutes late for practice. This is our skill today, not just with time, but with all types of measurement problems. You can see we're going to work on this standard here where we are solving one-step real-world problems, okay, and including all sorts of different measurement things. And actually today we're going to look at time, mass, volume, and length. We know what time is. We were just exploring volume in the last lesson, right? Remember when we put things in water? Length, we've been doing that with rulers a lot. Mass, got to go way back to when we were weighing things with a balance. I shouldn't say weighing because mass and weight are a little bit different, but for our purposes, they're pretty close. All right, when we are looking at a word problem, we can think about these two questions at the top. See them? What do we know and what do we need to find out? So our first question says, a sip of water is about 10 milliliters. About how many sips would it take to drink 130 milliliters? So listen to what I think here. What I'm going to do here is you know me, we gotta visualize. So I'm drinking some water here. Okay, and when I take one sip, 10 milliliters go down. Whoop. And I want to know how many it's going to take to get to 130. So I know, what do I know? I know how much water I drink in a sip, and I know how much I want to drink altogether. What I don't know, what we need to find out is how many sips I need. Well, if you're thinking, well, let's count by tens, I think that's a good idea. I'm going to represent that with a multiplication problem because if I do 10 times however many sips I make, right, this is the number of sips, that will equal 130. And so this is my goal to figure this out. Counting by tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, then 110, 120, 130. It takes 13 sips to drink 130 milliliters. See how we're doing that? All right, let's do this one together. A runner takes larger sips after a race. She drinks about 20 milliliters per sip. How many sips does she take to drink the 180 milliliters in her water bottle? All right. Do you see the runner? See her in your head, right? She's at the track maybe. And what do we know? Tell me one thing we know. Okay, you could have said, we know how much she drinks each time. We know how much she needs to drink, right? What she wants to drink. What do we need to find out? What do we not know? We don't know how many sips she takes, right? This is modeled off of the last one. So, how could we think about this? How might we solve this? We're going to figure out how many 20s are going to get us up to 180. Now, I did a multiplication problem last time. I could also just count by that number, multiples of that number. 40, 60. Yeah, that's where I'm going next. 20, 40, 60. What would be the next number? 80. And I'm trying to get up to 180. 100, 120, 140, 160, 180. Let's see how many sips it was. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sips. Okay, in a sentence, what's her name? Do we know her name? Nope, we don't. A runner would need to take 9 sips from her water bottle. I could have represented this with multiplication also, right? No, not 9. I would do 20 times something equals 180. If you want to get really crazy, we could throw some division out here. What we actually did was 180 divided by 20. Okay. But all of those are different ways to represent this. Boy, there's a lot of stuff on that screen, isn't there? All right. Now, we're actually going to pick one of these that we want to do together here. You've got 2 math journal pages that you're going to be working on. Go ahead and turn to page 224 and 225. All right, and I'm going to take one of these and try to make it a lot bigger so that we can see better. Here we go. And I'm going to toss that one over here for now. And we'll zoom in. Oh, that's better, isn't it? Let's see. Let's vote. Should we do number 1, number 2, or number 3 together? I want to do number 2. Did you vote for number 2? I hope so. Number 2, the city zoo is home to a male African lion. After the lion arrived, he gained about 8 kilograms of mass each month for 8 months. He now has a mass of about 186 kilograms. What was the lion's starting mass? Whoa. All right, so what do we know here? Hey, we know several things. We know it's a lion. We know that he was getting 8 kilograms, right? That's a measurement of mass or for our purposes of weight. And he did that for 8 months. So he did that 8 times. Oh, I gave a hint there, right? He now has a mass of 186. What was the lion's starting mass? All right, we have to work backwards here. We know that he's 186 kilograms now. We want to know what he was way back when he started. So my first question is, how much, why don't you figure this out? I bet you can. How much weight did he gain? Not how much was he now, so don't use this 186. How much weight did he gain? He gained 68 kilograms. Did I say 68? 64 kilograms. Boy, my words are not working right today. That's okay. Some days are like that. 64 kilograms. How did I get 64? I did 8 times 8, right? 8 kilograms each month for 8 months, right? 8 in January, 8 in February, 8, 8, 8, 8, 8, 8, 8. I could add those all up, but it's easier to multiply. Our first number sentence, 8 times 8 equals 64. And so this is what he was at the end, right? So our question is, what was the lion's starting mass? This is what he was at the end. So will our answer to this question, will it be bigger or smaller than 186? It has to be smaller, right? He didn't lose weight. We want to know what he was when he started. To make our answer smaller, we need to subtract 186 minus 64. And once you do that problem, you will know what goes here. Now, I'm going to let you do that. Okay? You're going to take that answer, you're going to put it right there. And then make sure to put the unit, kg, for kilograms. Okay, you're going to put your answer right there. So your job today, we did number 2. You're going to do number 1 and number 3. And of course, if you didn't do number 2 with the video, then you need to do that. And then you have 2 problems over here on this other page. Hello, other page. That you use the picture for. Okay, so some things with milliliters. We've been talking about that a lot lately. Oh, some more with milliliters. So you have these 5 word problems to try today, because that's what our objective is. That's what our goal here is to be able to solve number stories involving time, mass, volume, and length. Okay. All right, third graders, that's all. Be careful readers, right? If you read a problem and you don't understand it, it's going to be hard to get it right. So we're going to need to do some rereading, some visualizing, some thinking, right? And really focus to be able to understand those questions. Good luck.